So we're going to talk about Fusion Solar, which is what we call our PV division for sustainable business. Okay, to give you a quick business overview of Huawei itself. So we belong to a department in Huawei which is called Digital Power, and in Digital Power, we've done in 2022 $7.67 billion globally. Okay. And this is from 2021 to 2022, we had an increase of 64%. So from 4.68 billion to 7.67 billion. That's what we did. The main contributors is smart PV, which is our biggest income revenue. Then we also do data centers and critical power, which is your UPS stuff. And we also do what is called M-Power. Everyone knows that electric vehicles are taking off, and Huawei produces electric vehicle engines. So we call it e-power, the drives. And we also produce the battery chassis, charge controllers, and so on. Okay? So that's also taking off. In our digital power business, we are in 170 countries, and we have over 10,000 employees. 60% of our employees are in R&D. So R&D is a big thing for us. We have 12 R&D centers across the world, and we spend more than 10% of our revenue in R&D. So we have strategically placed our R&D centers. For example, in Sweden, in Stockholm, we've placed our R&D center which focuses on algorithms. That's because most of the mathematicians, or the top mathematicians, are from Sweden. In Germany, in Nuremberg, we focus on our power electronics, so the semiconductor business. And that's because in Germany, they are actually the talent for semiconductors is there. And then in China, in Shenzhen and Shanghai, we have our development centers there as well. Okay. So we are the largest inverter manufacturer in the world. Okay. As of last year, we shipped 300 gigawatts since 2015. Okay. Last year, we did 90.7 gigawatts of inverter shipments, and we did 6.8 gigawatt hours of energy storage systems. Okay, this actually is equivalent to 230 million tons of carbon emissions that have been reduced, and equivalent of 313 million trees that have been planted. Okay. Okay. Let me talk about Fusion Solar commercial industrial grid-tied inverters, which most of you guys are familiar with. This is our less than 1 megawatt string diagram. So your SLD, you can see that you have your PV modules here, you have your inverter, you have your smart dongle as well connected here. This is your loads. This is a smart power meter, and this is obviously the grid. And then this is also connected to our Fusion Solar portal via the smart dongle. Okay. Here you have PV inverters from 12 kilowatt all the way up to 100 kilowatt or 115 kilowatts. Okay. Greater than 1 megawatt, this is kind of the solution or the string diagram that you see. You have your inverters connected in parallel on the AC side, which is then connected to the load, which the load is then connected to the grid. Okay. And here you also have what we call a smart logger. So anything greater than 1 megawatt, we suggest having a smart logger, which is the logger that communicates with all the devices as well as communicates with the portal. And this can also communicate with accessories like weather stations and so on. Okay. Basically, this is for rooftops of schools, hospitals, factories, shopping malls, etc. The largest shopping mall now is about 6.8 megawatts rooftop. Okay, so it's a mall in Richards Bay, not with Huawei. Okay, so we have the smaller range, which is for your smaller size. Got a 12 kilowatt, 15 kilowatt, 17, 20 kilowatt. This has 2 MPPTs, 4 inputs, so 2 inputs per MPPT. The MPPT current is 27 amps, and the short circuit current is 39 amps. This comes with built-in WLAN, but you can also add communication devices like a smart dongle, smart dongle 4G, or the smart logger. This comes standard with arc fault circuit interrupter, which I will talk about later. Also comes standard with PID recovery, okay? And it has the ability to use optimizers. This has a natural cooling convection, so there's no fans in the smaller ones, okay? Then you have the 30, 36 kilowatt, 40 kilowatt, and 50 kilowatt. It's got 4 MPPTs with 2 inputs each, so you can connect 8 strings. It's got 27 amps, and then it's also got 40 amps short circuit current. Built-in WLAN, again with all the accessories on the dongles. Also AFCI, PID, optimizer ready, and natural cooling as well. Then we also have another version here, which is the Sun 2000, the newer one, 12, 15, 17, 20, 25, M5 version. It's similar to the other one. The difference is you've got 30 amps rated current, and then the short circuit current is 40 amps. Okay, it's got built-in LAN, it's got all the rest. AFCI, optimizer ready, smart air cooling. This has got smart air cooling, so this one's got fans in there. Okay. Okay. Then the new 100 kilowatts, 400 volt, 3-phase inverter. There's 2 versions. We've got 100 kilowatt, 115 kilowatt. It's got 10 MPPTs with 20 inputs. The short circuit, the MPPT current is 30 amps, and the short circuit current is 40 amps. This has a USB WLAN adapter. You would need to also, you could use the Smart Logger 3000 or the Smart Dongle 4G optional. Comes with AFCI. Nope, does not come with PID. Okay, it's optimizer ready. It's got smart air cooling, and it's got something new which is called Smart String Level Disconnector. So I'll touch on the Smart String Level Disconnector. The Smart Level String Disconnector is actually a switch that if it detects any faults on the DC side, it automatically switches off. And you cannot remotely switch it back on, because you need to go to sites and check where the fault is. Once you fix the fault, you can reset that smart string disconnector. What would happen on a product that doesn't have this is that the inverter will keep switching on and off and keep detecting the fault. Switch on and off, detect the fault, switch on and off, detect the fault. That could lead to, let's say there's an arc, or there's a break in the cable, or there's a problem with the module. You could damage the inverter, you could create a fire, you could do all of that, okay? So this is added safety that we added to this inverter now, okay? Communication modules, we've got the Smart Dongle WLAN. This supports up to 10 devices. So if you are using anything from 1 to 9 inverters or 10 inverters, then you could use the Smart Dongle. It's much cheaper than the Smart Logger, okay? Then if there's no internet, then you can go for the Smart Dongle 4G. So you can put a SIM card in there, and then you can also communicate with internet via that. And then we have the Smart Logger 3000, which supports up to 80 devices. We recommend this for any projects over 1 megawatt or more than 10 inverters, okay? All right, this communication device is very smart. It has communication with the cloud. It's got Ethernet capability. It can access weather stations, and also you can also pull data from it as well. So it can also communicate with third-party devices like a Incombi, generator integration, or a microgrid controller as well. So this receives all the commands and then sends the commands to the inverters, okay, from third-party devices. So you would need this if you're going to do any sort of microgrid controller or a generator integration controller and so on. Okay. We do have APIs as well. So if you want to use a third-party monitoring platform or a third-party business intelligence like a Microsoft Dynamics or something, you can pull the data across. Okay. We have optimizers. We've got 3 optimizers. We've got a 600 watt optimizer. We've got a 1100 watt, and we've got a 1300 watt. The 1100 and 1300 watt is one optimizer for 2 panels. So if you're doing anything from a 550 watt, you can have the 1100 watt optimizer. If you're doing 650 watts, you can do the 1300 watt optimizer, okay? So the optimizer itself, you could 0 volts on the roof. The max input voltage is 125 volts. The max short circuit current is 20 amps. The max efficiency is 99.5%. Shutdown output voltage is 1 volt. It weighs 1 kilogram. It's got MC4 connectors, okay? So this optimizer will allow you to actually go to 150% PV. So with 100 kilowatt, you can do 150 kilowatts of PV, okay? 100 kilowatt inverter, you can do 150 kilowatts. Then we also have our two smart power sensors. We've got the first one that comes with its own CTs, but is limited to 250 amps, okay? So if your current is more than 250 amps, we do have a different model where you can buy third-party CTs that have higher amperage, okay? So what is the solution value for Fusion Solar? So this is just an example, a topology that we're looking at. So you look at it, we've got modules on the roof here which have the controller, which is the optimizer. Then we have the smart PV inverters that are mounted on the side of the building here. Then you have your smart string ESS, which we'll talk about later. That's ground mounted here on the bottom here, like where a generator would be. So this is a 1+3, one fits all scenario, okay? So basically you can see there would be shading from this side on this panels. There would be some shading on the roof and so on. But because of the optimizers, you can still go ahead, okay? So you get optimal electricity cost. You get 5 to 30% more energy with using optimizers, up to 30% more modules as well, okay? Because you could normally do about 120%. So the added 30% makes you go up to 150. You've got a smart PV controller, which has potential induced degradation to secure the module performance. And you've got the smart string ESS, which you can achieve 2% more usable energy with modular plus optimization, which is our key topic today. Okay, module mismatch. I don't know if you guys know, but module mismatch is becoming a big thing now, especially if you're using higher wattage modules and you're using bifacial modules. It's a big problem. So mismatch is becoming quite a big thing. They talk about after 5 years, the mismatch grows to about 7%. Currently, look at something like 3% mismatch. So you're losing 3% generation. But after about 5 years, that 3% can actually become 21%. That's a big difference, okay? But if you have optimization and if you have multiple string MPPTs, then you can minimize that 3% to 1%. So you could actually change from 3% to 1% mismatch loss. And then after 5, 6 years, it's only going to be 7% loss, not 21%. Okay, that's the difference. Okay, you guys know about mismatch, why there will be mismatches, because the panels are not all equal. They're different. Some are 551 watts, some are 550 watts, some are 549. And then they degrade. In the first year, some lose 2%, some lose 1.8%, some lose 1.5%. So they're all different. What happens is that obviously it's all connected in series. So you are then now the lowest performing panel in the string is what you are actually getting, even if the other ones are higher. So if the other ones are producing high, you still will be limited by the one that has the lowest current. Okay. On the optimizer, we're talking about 5 to 30% more energy. You've got different scenarios which have different benefits or different amounts of yields that you gain. So each plant will have a different scenario depending on shading, depending on angle, azimuth, all of that, okay? So we did a case study in Shanghai where the module mismatch was caused by shading, our module mismatch was caused by dust, and after doing optimizers, the energy yield increased by 5%. Okay? Up to 30% more modules. If you look at the diagram on the left, they didn't put panels in that area because in the afternoon they're shading. So they opted not to go for that. With optimizers, you can put 30% more panels as well because you can cover that area that is shaded, and those panels don't affect the performance of the other panels. So the net effect is anything from 5 to 30% more power. Okay. PID. Anyone knows what's PID? Yeah. So it's called potential induced degradation. So it's a phenomenon that solar panels suffer from because of the aluminum framing. So the aluminum framing together with the glass allows positive ions to interact with the substrate, okay? And that causes degradation. You would only notice it after time. If you do some infrared photographs of the panels, you'll see that there's some degradation in the panels itself. So we have on the inverters from 50 kilowatts and below, we have anti-PID built in, okay? So let me tell you what anti-PID does, okay? So the PID recovery that we have, that function, what it does is that at night, we will offset that positive ions by sending a negative voltage to the panels. So we offset it. And we've done a case study where before and after, if you look at the pictures here, you can see the infrared photograph before and after. And we've got a 2.99% increase in the first year by doing PID recovery. Okay? So this is something that happens. Your plant without PID recovery will always have potential induced degradation. It's an inherent phenomenon that happens to solar panels. Okay.
So why don't you have it on the grid scale 115 then?
So we don't have it on the bigger ones, but we do have something called an anti-PID module. So we have something that negates the effect of anti-PID, but we can't recover it. So it's connected to our smart logger. So it's an anti-PID module. The anti-PID module will then prevent PID from happening, but it can't recover it. It can't recover it because we are unable to offset that negative ions in a safe way on such big plants. Because remember, let's talk about a megawatt plant. It's not as easy to do it on a megawatt plant than it is to do it on a 50 kilowatt plant. So remember.
You say you can't recover it. What does it mean that if you install it in the beginning, it will slow the process down?
100%.
Okay.
It will slow the process down.
Whereas the smaller ones, you're actually able to regenerate the
Yes,
cells.
100%.
Okay.
We're able to regenerate it. Perfect. Good question. Okay. This is a snapshot of our ESS just to talk about achieving 2% more usable energy. Because we have pack level optimization on our battery storage system, we can make sure that each battery is got its own battery management system that actually makes sure that it has its own state of charge done every day. So it calibrates the battery every day so that you can have the full usage of the battery. In traditional systems, you have to manually go do SOC calibration, which is only done maybe twice a year or once a year. So if one battery is 95% and the other batteries are at 100% connected in series, you only can draw 95% out. Okay, because they are mismatched in the battery cells itself. Okay. This is a scenario again. We're talking about with the ESS. We've got active safety, smart PV controller, active arc protection. We've got the smart module controller, which is a 0 volt on the roof. And we've got our smart string ESS, which is modular plus safety. It prevents risk in advance. Okay, this is just a snapshot. I'll show you what we're talking about. Electric arcing is threatening the safety of PV systems and underlying buildings. Okay, so what causes electrical arcing? Okay, unreliable solder joints on the PV modules, breaks in the cable, or loose PV connectors. This can happen in multiple ways, okay? There could be a defect in the solar panel. The broken cables could be from pulling cables. You kink the cable and it broke. And you also have loose PV connectors. The other thing we have in South Africa is rodents. Rodents chew on cables. They love cables. I'm not sure why. But they can also bite through the cables and create that kink in the cable. The risk is that these things actually arc at something like 3,000 degrees. And you can't stop that arc, okay? Right? You can't put anything to stop that arc unless you have a circuit which can interrupt the connection between positive and negative, okay? So there's an example of what the arcing looks like. It's continuously arcing, all right? It's without AFCI. And on the other screen, you can see, showing, yeah. So you see in the other screen, it stops. Okay, let's play this one. Okay. So you see it immediately stops, okay? So we can do 150% better than any competitor because we can detect an arc up to 200 meters. So a standard solution can only detect up to 80 meters. That's one of our competitors. We can also detect the arc, which is up to 30 amps, and our competitors can only do up to 16 amps, okay? Okay, so this is just an example. You can also pinpoint where the arcing happened. So the monitoring system will tell you string number 10 had an arcing fault. We switch the inverter off. Then your technician can go to string number 10 on the roof and go and locate the fault and find out. In other solutions from competitors, you have to find a needle in a haystack. Okay. Zero voltage on the roof. This is coming, guys. It's going to come as a fire safety, not from NERSA, not from NRS, not from SANS, but I know currently you can see, I'm not sure, firefighters and fire stations, their forums and so on will eventually come with this, because I've seen it already. Some of the international insurance companies, so a international company has a global insurance company and they require this, because if there is a fire on the roof, firefighters can't go and throw water on there if there's still DC voltage. They will get electrocuted. So having optimizers will allow you to then 0 volt the panels on the roof. So the optimizer itself will 0 volt them on the roof. So you can then throw water on there and it's safe. Okay. Previously there were some standards where you needed to have an emergency disconnect switch and all of that for firefighting and so on. But reality is that if the sun is out, there's still 1,000 volts on the roof. So the only way to negate this is to have optimizers on the panel. So you will see now, coming in the future, a lot of these small rooftops, 100 kilowatt, 200 kilowatt, will have this as requirements. Okay. You can sell it in a way that say that the benefit is that you comply to the safety standards for firefighting, and the other benefit is that you can get up to 30% more yield. Okay. You can also put additional panels in areas that you couldn't before because of shading and or chimneys and HVAC systems and so on. So you can make full use of the roof as well. Okay. Prevent risk in advance. So on our ESS, we have active safety, okay? We've got multi-level shutdown and protection. Faulty packs and racks are disconnected and isolated. So if you have a battery pack that we detect as a pre-warning that there is some lithium plating or there's some short circuit current there, we disconnect that pack automatically. Then you do a warranty claim and we give you a new pack, okay? All right, we've got rapid system disconnection switch as well. So someone who's on site and they want to switch off the system, there's a button to press, it'll switch off the whole thing. And you've got one-click shutdown for the whole thing if there's thermal runaway, okay? We've got proactive alarms, so smart internal short circuit diagnosis. We've got pre-alert and bypass the faulty cells, fire risk point monitoring, massive sensors monitoring system exception. So we've got temperature sensors, smoke detectors, flood sensors, all of that. And we've got live insulation monitoring. You've got your ISO and IMD pre-alert short circuit risk as well. Okay, we'll go into detail on that. So effectively, we've got some smart O&M as well. So smart module controller, so you've got less than 40 seconds to do your module physical layout creating. So you can create your layout on our monitoring platform. You've got easy management of each module anytime, anywhere. Okay. You've got smart string ESS with automatic state of charge calibration, smart PV controller, one dongle for one PV plant. and you've also got built to last for decades. So it's got electromagnetic current as well, and best-in-class reliability, providing a qualified inverter. 40 seconds. So in the Fusion Solar app, while you're commissioning using the commissioning tool, you click device management, physical layout, design of PV modules, and you click camera. So you can take a snapshot of the installation, and that will then take a photo and create the module physical layout template pasted with a optimizer, QR codes, and wait for detecting of optimizer QR codes completion. So you follow all these steps and you'll be able to do a layout. Basically, with the optimizers, you can then dial down to every panel. You can see the voltage for every panel, you can see the current for every panel, and if you run a report, you can see if there's a PV module that's not performing, okay, based on the rest of them. Okay. Module level monitoring, this is what I just explained now. So you can monitor each PV module individually. That helps to identify any modules that are not working properly, have micro cracks, have diode problems, or they have a cracked panel, okay, or it has hot spots. Okay, automatic calibration. So our battery does automatic SOC on a daily basis. So we make sure that each battery is fully charged to 100%. Once it's charged to 100%, it's then bypassed so the other batteries can charge, and you don't do overcharging from one battery to another battery. Okay. Normal SOC calibration for a competitor would mean that you need to go to site, stop the system, connect up to each battery, do the calibration. So on a 100 megawatt hour plant, it's 300 man days. 10 megawatt hour plant, looking at 3 days. Okay. $30 days, sorry. Connect up to 10 devices with our dongle. So one dongle for one plant. So if you've got a 1 megawatt, you can connect 10 inverters with one dongle. So the one dongle is on the master inverter, and it receives all the information from the slave inverters. Electromagnetic compatibility. So we've got a unique 3-layer EMC protection design, and we've got our own EMC test center. So we've done it on the DC side, the AC side, and the enclosure itself. So we've got a sealing strip as well within the inverter. So it's a full IP66 inverter with the unique 3-layer EMC protection as well. Design process, thoroughly tested Huawei inverter. So we test everything thoroughly within our own test facilities, as well as we use third parties. So we've got an annual failure rate of 0.5%. Anyone knows what the industry failure rate for inverters are? Idea, guess? 2%. So the industry failure rate for inverters is 2%, okay, on average. Okay, I don't know about the other ones. Tafara, this other ones, what's the failure rate? 5%, 10%? You tell us. I heard there's 1,000 inverters in Randburg. Okay, so let's move on to the topic that we are here for today, which is the Fusion Solar Smart String ESS. Okay, so this is a containerized solution. Okay, it's a 200 kilowatt hour. We call it 200 kilowatt hour, but it's actually 196 kilowatt hours. We've got 12 battery packs in there, which are 16.13 kilowatt hours each. Okay, and this is 0.5 C. Okay, so we only can do 100 kilowatts in backup. So 100 kilowatts for 2 hours. Okay. But somebody said they know the owner here. Who is the person here? Why did we not sell the? We didn't sell the solution here. Tafara, just do a site survey. So application solution, okay, so we've got an on-grid PV ESS solution. This basically, guys, I'm telling you because there are certain mines and certain key points, whether it be government buildings or whatever the case is, clinics and so on, will eventually be in a situation where they won't be load shedded. They will be in a situation, currently mines have what we call curtailment, so they won't be in load shedding, but they're asked to reduce their power usage. You'll get clinics and, I mean, the guys are punting for clinics and schools and so on to be in a situation where they won't be load shedded. The problem there is that they're all sharing the same substations, so they would have to have many subs separate so that they don't have to switch them off. But that is why we're talking about on-grid. For on-grid, you can do maximum self-consumption, frequency regulation, time of use, peak shaving, and grid reinforcement as well. For that, you could use the following items: an optimizer, inverter, ESS, meter, and SACU. When we're talking about off-grid, which is our on-off grid scenario, okay, the application scenario will be for backup purposes only, or for a microgrid where there's no grid at all, okay? Here you would need all of the items in the beginning here, plus you would need some third-party eco-cooperation. So you'd need a microgrid controller, you'd need an isolation transformer, you'd need a UPS, and you'd need an on-off grid switching cabinet, okay? We'll go into more details later. Just to give you some specifics about the unit itself, so number one here is your door-mounted distributed air conditioning. So this is a commercial grade air conditioning. It does not have any condensation, okay? So this is what you need for your batteries, okay? All right? You've got your battery packs, which are inside here. So each battery pack here, it's a lithium iron phosphate compound, 16.13 kilowatt hours, okay? Then the entire container, we call it a battery rack. You've got your smart rack controller on the side here, which is number 4. Number 5, you won't see on the side here, it's a 100 kilowatt PCS. We call it a PCS. Basically, it's a charge controller that charges the battery in DC and discharges the battery from DC and then converts it to AC, okay? All right, and then you also have an safety button here, so you can abort it. Just go some 3 key factors in the data sheet. It's 193.5 kilowatt hours, 0.5 C is the rating. The enclosure is 1.8 meters by 2.1 meters by 1.2 meters, okay? All right. The total weight of this thing is about 2.9 tons, okay? It's IP55 rated. This is actually made to go outside, okay? So it's IP55 rated to go outside. If you want to put it indoors, we don't recommend it, but there is parameters where you need to have ventilation. So certain room from the wall and this and certain amount of ventilation, okay? It can operate in temperatures from minus 30 degrees to 55 degrees. Your storage temperature is minus 40 degrees to 60 degrees. Operating humidity range from 0 to 100% non-condensing. The EMC is class A here. Maximum altitude is 4,000. You've got communication ports like Ethernet, optical fiber. Communication protocol is Modbus, TCP, and it's RoHS compliant as well. Okay, this is your on-grid solution, right? Without PV, so you can parallel up to a maximum of 10 of these units. There's no PV. Okay, you've got your 400 volts connection here, which is then connected to the load. There's a smart power meter in between here. This is your council transformer, okay? That's there, and that's your load, okay? All right. And here you connect it to your loads, and then you also got your communication device connected here, which is then connected to the smart power sensor. So in this on-grid scenario, there's no additional equipment needed. You only need the ESS, smart ACU, okay, and your smart power sensor in your on-grid application, okay? This is a simple, easy one. Now we're introducing the solution with our M3, V5, and V5 plus inverters. So these are all the new inverters that we're talking about. Okay, if you look at this scenario here, you've got your load, you've got your PV, your inverter on the same line, okay? You've got your ESS, which is a max of 5 units with PV on the same line, and you've got your power distribution cabinet here, which is then you've also connected to your communication device, which is connected to your power sensor. And then you've got your step-up transformer for the municipality. This is also a very simple on-grid solution with PV, okay? So these are only for where there's no load shedding, okay? Your PV solution, on-grid solution without Huawei inverters. So if there's an on-grid solution without Huawei inverters, we have third-party inverters. The only difference is here is that between the inverters and the ESS, you need to have an isolation transformer. So there's no backfeed DC into your inverters. All the new Huawei inverters don't need this isolation transformer because we have the communication between them, okay? But if you're using third-party inverters, you need to have an isolation transformer in between that prevents the storage solution from feeding DC back into the inverter, okay? All right, you'd also need, and in addition, you'd need a third-party microgrid controller as an additional extra, okay? On-grid solution. So there's no need for backup for the microgrid because it's on-grid. Okay, on-grid solution. So this is the same with other than the M5 or other than third-party inverters. It's exactly the same, okay? This is what we're all interested in, which is the off-grid solution, okay? So the off-grid solution with PV. So you've got your PV panels, your inverter, which is connected to your on-off grid switch, which is then connected to your critical loads and your common loads, okay? And you have this is how you distribute the loads here, okay? In between here, you'll have to have an isolation transformer, which is a 400 volt isolation transformer. You can have a max of 5 ESSs connected here. In addition, you also need a UPS for your microgrid controller, okay? You'll also have your power sensor here. So in this scenario here, okay, all right, you're required to have any of the inverters on the new inverters, which are the M3, V5 inverters, or the 100 kilowatt M1 or M2 version. Third-party inverters cannot be supported in this off-grid solution, okay? Quantity of the ESS connected in parallel is max of 5. The isolation transformer is there because it provides the form of 3-phase 4-wire system supply for a 3-phase unbalanced load and single-phase load. It is essentially, due to the PCS, is a 3-phase 3-wire system, okay? So we cannot provide to unbalanced loads. The PCS can only provide 33 kilowatts per phase. The isolation transformer will assist in providing unbalanced loads as well, okay? You also need a UPS because when the grid goes off, your microgrid controller needs to still be able to communicate with the other devices and give commands. Okay, any questions? Okay, everyone understand? So this scenario is with a DG generator. So it's exactly the same as the previous one. Only difference is that you'll also have a diesel generator here. So the diesel generator can work in cold standby mode, okay? So this scenario is cold standby mode, meaning that we can do on-off switching of the generator. When the batteries reach a certain level of state of charge, call it 10%, we then can command the generator to switch on and charge the batteries up to a certain level again, which is maybe 40 or 50%, and then the generator switches off again. And then when it reaches 10% again, it'll switch on again and charge the batteries again. Okay. Okay, off-grid solution where the DG as the main power. So there's no grid, ESS and DG as the main power. You can see here, you're still going to put 5 together, your PV, your inverter, your diesel generator is connected on this part of the line, okay? You've got your power distribution facility here, your loads are here, your microgrid controller is here, you need a UPS. I'll send you all this so you can have a look at all these diagrams and how it is connected, okay? So this is now in a microgrid solution. Okay, some reference cases, guys. We've got a 3 megawatts Shanghai metro project in China. So green power metro stations in Shanghai. The energy generated can allow an 8-cabin metro train to run 200,000 kilometers, which is equivalent to more than 1,560 round trips. Okay, this is using our Sun 2000 125 KTL. Okay, and the storage solution. Okay, another case is the 7.8 8 megawatt solar park in Germany. Okay, the solar park operates without Germany's Renewable Energy Act (EEG) subsidies for the first time and helps to move one step closer, offering customers 100% green electricity by 2024. This is our utility scale inverter, 185 kilowatt inverter that was used here. Okay. We've got a 140 megawatt steel industry PV rooftop project in Turkey. Here it's using 100 KTL configuration here. Okay, so it's got 260,600 watt modules. It's got 1,400 Sun 2000 100 kilowatt inverters. It's got 156 megawatts of PV panels. You can see some of the pictures here. That's the rooftop that they're using. This is the inverters that's installed there, and so on. Okay. That's it. Any questions? Everyone's tired. I don't like the afternoon slots. So anyone have any application cases that you want to talk about? Okay, let me tell you about the case study for this. Okay, so basically, this ESS solution was designed for petrol stations. So almost all petrol stations have a 100 kVA generator, and they either have 50 kilowatts of PV on the roof, or they have 100 kilowatts of PV on the roof. So this is basically, we're going to rip out the generator and put this in. That's the case. That is the use case that we've got. So it can be adapted for different scenarios as well. Chicken farm. There's a chicken farm that we're working on. There's office buildings that we're working on. There's shopping malls, small shopping malls that we're working on. There's lots of stuff. Okay, we sold 10 units already. So 10 units are sold, and we expect to get orders for quite a lot. The key reasons why, okay, that the guys are going for this solution, we've actually reduced the price as well. The price has come down quite a bit. The reason being that lithium prices have dropped by 70%. So the cost of lithium has dropped, so the prices have gone better. And there's key reasons why they choose. Because you're choosing Huawei because it's one vendor for the battery, for the inverter, for the PCS, for the monitoring system, it's one vendor. Okay, with the other systems that are out there, you've got one inverter manufacturer, you've got another battery manufacturer, you've got another PCS manufacturer, you've got maybe two monitoring systems, one for the inverter, one for the PCS, or three even, one for the BMS for the battery. So there's a blame game going on. The thing doesn't work. It's not my fault, it's the battery. The battery, no, it's inverter, no, it's this. So there's a blame game going around. That's one of the key factors that's happening there. The other thing is that we're doing 100% depth of discharge. You can discharge this battery to zero. We give you 5,000 cycles, okay? Or 5 years or 10 years, depending on what you choose. It comes standard with 5 years. You can upgrade it up to 10 years warranty. So we give 5,000 cycles or 5 years or 10 years, whichever comes first, okay? And the end of life capacity is 70%. So at the end of the 5,000 cycles or the 5 years or 10 years, the battery will still have 70% capacity in it. Okay, that's our guarantee. We don't do repairs. We don't repair anything. If the PCS becomes faulty and it's a warranty case, we give you a new PCS. If the rack controller is faulty, we give you a new rack controller. If the battery pack is faulty, we give you a new battery pack. It's hot swappable. Don't have to do anything. We bypass that battery pack that's faulty already on the system, send you the new one. New one is there, you disconnect the old one, you put the new one in. Okay, that's it, you continue. That's Huawei's warranty. We don't repair, we replace. Okay? All right, so that's the one good thing about Huawei. We do state of charge calibration every day. So you 100% guarantee that you'll get full discharge capacity of the battery. Okay? There's no mismatch between battery packs. It's got a fire safety module. It's not a fire extinguisher that's holding the door open, okay? It's a fire extinguisher module that's inside the cabinet itself. And that fire extinguisher module can contain the fire within the cabinet for 1 hour, okay? I don't know if you guys watch a video of any lithium-ion batteries burn. It doesn't stop. You can't stop it. It can burn for days. The one in Australia, Tesla, burn for days, guys. Burn for days. And you can't use normal water. You've got to have a special chemical for this. So we've got that fire extinguisher module has a specific gas in there where it bonds itself to the oxygen molecule of the LFP. So inherent in the LFP, one of the molecules of the battery cell is oxygen. Okay? So we've got the chemical that bonds itself to the oxygen molecule and converts it to sulfur. And that's how we stop the fire. Okay? And we try to contain. But prior to all of that, this unit is connected to the internet. We've got an AI-based battery management system in our cloud software that is monitoring the batteries continuously, pinging the battery and checking for lithium plating, short circuits, currents, all of those tendencies. And it will warn you in advance to switch off this battery pack. There is a problem, we'll switch it off remotely and all of that. If all of that fails, then we still have the fire safety. Okay. And we also got this gas that I'm talking about. When it disperses, it creates a pressure inside the cabinet. And we have our catches on the top, so the lids will blow off on the top, will open on the top, rather than the doors opening, and if someone was next to it, it hits them, and then it's dangerous. So in terms of health and safety, we cover that. Okay. Okay. Looks like we're done.